Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video we discussed about biasing techniques used in MOSFET, and I also told you about a circuit which is called as a current mirror circuit and its application in current steering circuit. So what we'll do in this video is we'll solve some problems based on the circuits that we have studied so far, and you will understand how to use the concept of biasing. So let us start with our first problem. In the first problem it says, in figure, the n-channel MOSFETs are identical and their current voltage relationship is given like this. Now see, when VDS is less than VGS minus VT, that means it is talking to us about linear region. When VDS is greater than equal to this is saturation region, where VGS and VDS are gate source and drain source voltage. ID is the drain current. We need to find the current IDC that is flowing in M. Now first thing that you need to see is that the gate and drain are connected together. I told you when G and D are connected, so MOSFET is in saturation region. Now we know this M is in saturation region. What we need to do is we need to find its current. But in order to find its current, we need the value of VGS. Now gate and drain voltage is equal. Suppose this voltage is V. So what is VGS? VGS equal to V minus 0 equal to V. Okay. This we know. Now see the other transistor. Let me call it as M2. The gate voltage is 0. Source voltage is minus 2. So what is the gate to source voltage of second transistor? 0 minus minus 2. That is equal to 2 volt. Now from this equation you can see that the threshold voltage is 1 volt. So this VGS2 is greater than VT. Now what about VDS for this transistor? VDS. If you calculate VDS, it will be V plus 2. Okay. Which is definitely greater than VGS2 minus VT. Because VGS2 is how much? 2 minus 1 equal to 1. So V plus 2 is definitely greater than 1. So which means the M2 transistor is also in saturation. From here what I can do is I can calculate the current of second transistor I2. We will use saturation region. So VGS is 2 minus 1. So it is equal to 1 milliampere. Now this is the second current I2 or the current in second transistor. Just by KCL what you can say IDC is 2 minus 1 equal to 1 milliampere. Is my point clear to you guys? What I was telling is you cannot directly solve for M because the VGS is variable here. It is not known. So what did I do is I started with the second transistor. We knew the value of VGS and I found out its current. Once I found out its current, I applied KCL to find the current of the second transistor. Okay, that is how we solved this problem. Next question. A n-channel MOSFET having threshold voltage of 2 volt is used in the circuit. Initially T is off in steady state. T means this transistor. It is off in steady state. At T equal to 0, we apply a step voltage of 4 volt at the input so that the MOSFET turns on. We need to find the time for V0 to fall to 5 volt. Okay. So let us start this problem. It says that it is a problem based on transient. At T equal to 0 minus, the transistor is off. If the transistor is off, the drain current is 0, right? This current is 0 ampere. No current is flowing in the circuit. If no current is flowing in the circuit, the entire voltage appears across V0. So what I'll say? V0 equal to 10 volt. Suppose this is ground. I am taking this as reference. If V0 is 10 volt, what is the voltage across capacitor? The voltage across capacitor is actually V0. It is also 10 volt. Okay. Now in this case, if I ask you the drain to source voltage, the drain to source voltage is 10 minus 0 equal to 10 volt. Now when we talk about at T equal to 0 plus, we are applying an input of 4 volt here. So what is VGS? VGS is 4 volt. It is greater than VT because threshold voltage is 2 volt. But we need to decide the operating region, whether it is linear or saturation. Now see one thing. V0 is actually the voltage across capacitor, right? And the voltage across capacitor cannot change instantly. So that means I can say that VDS will still be 10 volt. VDS is actually the voltage across capacitor. It cannot change instantly. So it will also be 10 volt. So what I can say? VDS equal to 10 is greater than VGS minus VT. 10 is greater than 4 minus 2 equal to 2. Right? Once I know that VDS is greater than VGS minus VT, the region of operation is saturation. Now we need to find the time taken for V0 to fall to 5 volt. Now suppose at T equal to capital T, V0 is 5 volt. In that case, the drain to source voltage, which is V0, is 5 volt. And what about VGS minus VT? The gate to source voltage is 4 minus VT is 2. So that means still VDS is greater than VGS minus VT. So that means still it is in saturation. That means when I will be solving the problem, in the entire duration, my transistor will remain in saturation. It will not come out of the saturation. Now once I know it will stay in saturation, I can say that the drain current is K times VGS minus VT whole square. I can say this. Now see, let me remove these values. There is one current, that is the resistance current IR. This current is suppose IC. This current is the drain current ID. So by applying KCL, what I can say that ID is IR minus IC K VGS minus VT whole square. Now how can you calculate this current in the resistor? The voltage here is 10 volt and the voltage here is V0. So what is the current in the resistor? 10 minus V0 by resistance. What about capacitor current? It is C dV0 by dt, because the voltage across capacitor is V0, so C dV0 by dt. Now what is the value of K? K is given as 5 milliampere per volt square. 5 milliampere per volt square. VGS is 4, VT is 2. So that means 10 by 1 kilo ohm is 10 milliampere minus V0 minus C dV0 by dt. Now it is 5 milliampere. 4 minus 2 is 4. Sorry, 4 minus 2 is 2. 2 square is 4. So that is 4. Actually, it should be K by 2. So that is how much? 10 milliampere. Here I am assuming that this K is mu n COX W by L. That is the value of K that I am taking. And this value actually should also be given in the problem, that this K is mu n COX W by L, or it is mu n COX W by 2L. That thing should always be specified. Okay. Now, we can cancel this 10 milliampere with this. If you take minus sign common, V0 equal to minus C dV0 by dt. Now this is actually V0 by 1 kilo ohm. That means if I take like this, dV0 by V0 is minus dt by 1 kilo ohm into C. C is how much? If you see, C is 100 picofarad. That means 10 to the power minus 10. If you integrate both sides, initially V0 was 10. We want V0 to be 5. So this is 10 ki power 3, 10 to the power minus 10, 10 to the power minus 7. Initially time is 0, then V0 is 5 at t equal to capital T. So 1 by V0 integration is log V0. Integration of dt will be this. So if you put the limits from here, this time will come out to be 69.3 nanosecond. Okay, that will be the time at which V0 will be 5 volt. Other than this, see this information. The resistance capacitances are given as 0, because if there was any capacitance between drain and source, it will be added to this capacitance. Okay, so these type of capacitances will be used in frequency response when we will be studying frequency response. But right now it has given us these capacitances to be 0, which means there is no capacitance connected parallel to the 100 picofarad capacitor. Next, it says given an NMOS circuit as shown in the figure, and the specifications are VDD equal to 10 volt. See, K is mu n COX W by L. This sort of definition should always be given in gate. VT equal to 1 volt, IDS equal to 0.5. We need to find VDS and RD. Now it says neglect body effect for VT. This body effect we actually study in electronic devices and circuits. In this, what it does is, if you apply certain voltage at the body terminal, this is the body terminal, this is source, this is drain, this is gate. Now by changing the body voltage, we can change the threshold voltage. That is what it is saying. If you are neglecting the body effect, it means you are ignoring the change in VT. So you will assume that VT will remain constant. Now see in this problem that gate and drain are connected together. If gate and drain are connected together, what is the region of operation? The region of operation is saturation. Now in this case, what is the drain current? The drain current is K by 2 because it is W by L. If it was W by 2L, then I will directly use K. VGS minus VT whole square. Remember, in saturation region, the constant that comes outside is like this. But it is given as W by L, so I have divided it by 2. Now this VGS is nothing but, since gate and drain are connected together, VG equal to VD or VGS equal to VDS. So I can say that the drain current is K by 2 VDS minus VT square. Now this drain current is given as 0.5 milliampere. K is given as 10 to the power minus 4 by 2. VDS I don't know, but VT is 1. So when you take this 2 on the left hand side, 0.5 into 2 will become 1 and 10 to the power minus 3. So it will be 10 to the power 1 I am just taking both these terms on the right hand side, which means VDS minus 1 equal to plus minus root 10, or VDS equal to 4.16 or minus 2.16. Now VGS and VDS are both same, and VGS cannot be negative, otherwise it will be less than VT. For transistor to be on, the gate to source voltage must be greater than VT. So this value cannot be used. VDS is 4.16 volt. Now we know VDS. How to calculate RD? Just by KVL. So what I'll say, RD is VDD minus VDS by IDS. Okay. VDD is 10 minus 4.16 by current is 0.5 milliampere. So it will come out to be 11.68 kilo. Okay. So whenever you get multiple answers, you always have to check validity of each value. Otherwise, the answer might not be valid. Because here, if VGS comes out to be negative, then it will be less than threshold voltage and your MOSFET will not work. Next question. Now, it says for the circuit shown in the figure, transistors M1 and M2 are identical NMOS transistor. Assuming M2 is in saturation and output is unloaded. Output unloaded means here it is open circuit. There is no load resistor. We need to find the value of Ix in terms of I bias. Many of you might have already recognized this circuit. This is basically your current mirror circuit. If it is current mirror circuit, we know that Ix over I bias is equal to the ratio of their aspect ratios. Okay. But it says these are exactly identical NMOS transistor. So this will get cancelled. So Ix will be equal to I bias. So the answer would be B. Okay. Ix will be equal to I bias. That will be the final answer, because W by L ratio of transistors is not given. If it was given, then what will I do? I will scale the current on the basis of W by L ratio. I will not say that both currents are equal. Is it fine? So let us move on. The next problem. It says assume that the transistors M1 and M2 are identical. Identical means their K value will be same. K means mu n COX W by L. And have a threshold voltage 1 volt. We need to find their operating state. Saturation, saturation, linear, saturation, that sort of thing. Okay. So let us examine this circuit. Both are NMOS transistor, but this terminal voltage is not given. So let me assume V. So tell me what is the value of VGS for the second one, upper transistor. The gate voltage is 2.5 and the source voltage is V. What is the drain to source voltage of the second transistor? 3 minus V. Now, for the first transistor, what is the gate to source voltage? 2 minus 0, that is 2. What about drain to source voltage? That is V minus 0, that is V. Now see, for the second transistor, VGS2 minus VT, how much will it be? VGS2 minus VT will be 2.5 minus V minus 1, 1.5 minus V. What about VDS2? It is 3 minus V. Now you can say that VDS2 is greater than VGS2 minus VT. Okay. If it is the case, it is in saturation. But for the first transistor, if you calculate VGS1 minus VT, VGS1 is 2, VT is 1. So it is 1 volt. And what about VDS2? Sorry, VDS1. It is V. So we cannot compare these two values because V is unknown. But here we can say 3 minus V will always be more than 1.5 minus V. Are you getting my point? So we know the state of M2 is saturation. So there can be only two options, either A or C. The state of M2 is saturation. So we need to find the state of M1. Now what I will do is, I have to assume the state of M1. Okay. So I'll assume M1 is in saturation. Now based on this, you can calculate the value of I. I will be K, 2 means VGS is 2 minus VT minus 1 square. What about the current for this transistor? It will also be I. Both are connected in series, so their current will be same. It will also be equal to K. It is in saturation. What is VGS? 2.5 minus V. Minus VT is 1. So this gets cancelled. So 1 equal to 1.5 minus V whole square. So that means 1.5 minus V is equal to plus minus 1, or V equal to either 2.5 volt or 0.5 volt. So we have got two values of V. Here we know VGS 1 minus VT is actually 1 volt. If it is 2.5 volt, if V is 2.5, then VDS 1 is 2.5. It will be greater than VGS 1 minus VT, right? VDS 1 is equal to V, so it will also be 2.5, which means it will be greater than VGS 1 minus VT. That means it will lead to saturation region. But if V is 2.5, then this voltage will become 0. If this voltage becomes 0, it means M2 will be in cutoff. Because for transistor to be on, the voltage must be greater than the threshold voltage. VGS must be greater than threshold. So this cannot be the answer. What about 0.5? If it is 0.5, it is less than 1 volt. That means for this, the region of operation will be linear. So our assumption of M1 in saturation is incorrect. M1 must be in linear region. So the answer must be C. And let me show you how we will solve using linear region. Is my assumption clear to you? I assumed the region of operation as saturation and I found out the value of V. And then I have verified my hypothesis by calculating all the values that I have written on the right hand side. Now our M1 is in linear region. That means its current would be K, 2K, VGS minus VT. VGS is 2. 2 minus VT, 1 into VDS. VDS is V minus VDS square by 2. M2 is in saturation. K, VGS is 2.5 minus V minus VT is 1. So it will become 2V minus V square is 1.5 minus V whole square. Okay. So 2V minus V square, if you open the bracket on the right hand side, 2.25 plus V square minus 3V. So it will become 2V square minus 5V plus 2.25 equal to 0. If you solve this value, you will get V has two values, 1.9114 and 0.588. Now if you take 1.9114, 2.5 minus 1.9, how much will it come out to be? 0.6. But it will be less than threshold voltage. So this value is incorrect. This is the correct value. Okay. Because never, the gate source voltage should never be less than the threshold voltage. Otherwise the transistor will turn off. Okay. So whenever you see multiple transistors connected together, what you have to do? You have to equate the currents flowing in the transistors. Next. In the circuit shown, the W by L value of M2 is twice that of M1. The two NMOS transistors are otherwise identical. The threshold voltage for both transistors is 1.1 and VGS for M2 must be greater than 1. Actually VGS here is directly 2. So it is greater than 1. So this condition will not make much sense for us. Current through the NMOS transistor can be modeled as like this. So these are the equations that we generally study. It has given us directly those equations. We need to find the value of Vx. Okay. So again, let us start with the same method. First I'll talk about M1. Tell me the gate to source voltage for M1. The gate voltage is 2, source voltage is Vx. 2 minus Vx. What about drain to source voltage? 3.3 minus Vx. Now if I ask VGS1 minus VT, VT is 1.1. If you subtract 1.1, it will be 0.9 minus Vx. Definitely if you see this, VDS1 will be greater than VGS1 minus VT. It means M1 is directly in saturation. So we know the state of one transistor. Now tell me about second one, VGS2. 2 minus 0, it is 2 volt. What about VDS2? Vx minus 0 equal to Vx. Now you cannot compare VDS2 with VGS2 minus VT. If I subtract 1.1, which is the threshold voltage, it will be 0.9. So we cannot compare Vx with 0.9 because Vx is unknown. So the state of this transistor is unknown. So how will I start? I will assume M2 in saturation, because saturation equation is much simpler. So what you will do is, you will say that drain to source current, both transistors are in series, must be equal. So what is the drain to source current of the first one? Mu COX W by L. VGS is how much? 2 minus Vx. VT 1.1. What about drain to source current of second one? Second one we have assumed in saturation, so we will use this equation. Mu COX W by L upon 2. VGS is how much? VGS minus VT is 0.9 square. So this gets cancelled, this gets cancelled. So 0.9 minus Vx square equal to 0.9 square. If you take square root on both the sides, 0.9 minus Vx is plus minus 0.9. So either Vx is 0 or Vx is 1.8 volt. So there are two possibilities. Let me check. If Vx is 0, this saturation assumption will be incorrect, because for saturation, what is the condition for saturation? For saturation, VDS must be greater than VGS minus VT, which means for second transistor, Vx must be greater than 0.9. Okay. If Vx must be greater than 0.9, that means this answer cannot be possible. Vx can be 1.8. So let me now check Vx equal to 1.8. This condition is satisfied. What about this? If Vx is 1.8, VGS1 will become 2 minus 1.8, that is 0.2, and 0.2 is less than 1.1. So in this case, VGS1 equal to 2 minus Vx equal to 0.2 less than 1.1, that means cutoff. So this value is also not possible. So now what I'll have to do? I'll have to assume M2 in linear region. Our assumption was incorrect. M2 must be in linear region. Now when you assume M2 in linear region, the current must still be same. IDS1 should be equal to IDS2. IDS1 will be mu COX W by L divided by 2, because this is in saturation, right? So I can directly write this expression, 0.9 minus Vx square. What about IDS2? Now I'll have to use the expression for linear region, which means mu Cox W by L. What about VGS minus VT? VGS minus VT for this transistor is 0.9. 0.9. What about VDS? VDS is Vx. So 0.9 Vx minus Vx square by 2. So this will get cancelled. So if you solve this equation, you will get two values of Vx. First Vx will be 1.57 or 0.42. But we cannot use 1.57. Otherwise, again the gate to source voltage will be less than the threshold voltage. So this is incorrect. The answer must be 0.42 volt. So you have to check two conditions, that gate to source voltage must be greater than Vt and VDS must be greater than equal to VGS minus Vt. These two conditions must be true. So that is how I can frame question when multiple transistors are connected about the state of transistor. Moving on to the next problem. In the circuit shown, V1 is equal to 0. Okay. And other relevant parameters are mentioned in the figure. Ignoring the effect of channel length modulation and body effect, find I out. Now if you carefully observe this circuit is nothing but it is a current mirror, right? It is a current mirror type of circuit. So what will be this value? I will be the reference current, that is 1 milliampere, into W by L ratio of this transistor, that is 3, by W by L ratio of source transistor 2, 1.5 milliampere. Now it has given us one specific thing, that V1 is equal to 0. If V1 is 0, the gate to source voltage will be less than threshold voltage. So this transistor is off. But here V2 is connected as VDD. If V2 is VDD, high voltage you have applied. So this transistor will be on. If this is off, it will not carry any current. So the entire current I will flow like this. This current I in this circuit will go like this. Again, if you see, this is a current mirror circuit. Are you getting my point? It has given us V1 to be 0. If V1 is 0, it means this transistor is not conducting because gate to source voltage is less than threshold voltage. So only V2 transistor will conduct and it will carry the entire current 1.5 milliampere. Now this current will become the reference current for the PMOS current mirror. This bubble here, this bubble is also a representation of PMOS transistor. Okay. If there is no bubble, it is NMOS. If there is bubble, it is PMOS. So now you can calculate I out again by applying the relation of current mirror I into output transistor by source transistor. 1.5 into 4, that is 6 milliampere. So that way I can give you a complicated circuit to find the current in a current mirror circuit, and for that you just need to have strong basics about the MOSFET and current mirror. Moving to the last problem, it says consider a long channel MOSFET. Long channel means no channel length modulation, or also in EDC we study about short channel effect, so that will be absent. Channel length will be 1 micrometer, width will be 10 micrometer. So let me write down the parameter. W is 10 micrometer, L is 1 micrometer. The device parameter mobility is given as 800. Oxide capacitance is 3.45 into 10 to the power minus 7. Threshold voltage is given. We need to find the drain. This will not be rain, it will be drain. Saturation current. So the drain saturation current is how much actually? The drain saturation current is mu n Cox W by 2L VGS minus VT whole square. Now this mu n is how much? 800. COX is 3.45 into 10 to the power minus 7. W by 2L is 10 by 2. VGS. Now VGS is given us, gate voltage is given as 5 volt. Source voltage will take it as 0. VT is 0.7 square. So how much will this current come out to be? For that you have to substitute these values in calculator. So 10 by 2 is 5. 800 into 5 is 4000. 4000 into 3.45 into 10 to the power minus 7. What will be the bracket? Bracket will be 4.3 square. So it will come out to be 25.51 milliampere. Okay. So that is the saturation current of the drain terminal. So this is all from this video. I have told you how you can use the condition for linearity and saturation, and if I want to make a good question, then I'll give you multiple transistors connected in series and I can ask you about the states of different transistors. So solve such kind of problems very carefully, and if you have solved multiple problems based on this concept, it will be in your grip. You can always tell about the state of transistor. So this will be all from this video. From next video onwards, we'll start the amplifier modeling of MOSFET. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.